Arithmetic series and sigma notation. Arithmetic series and sigma notation. All right. Sequences and series, they are things that are new to your thought, going to require some review. I, just like you, honestly need to review these at times, and it takes me time. I'm not going to be quick off the cuff on these because I got to think what's going on, and you do too, and you're going to have to review if you're going to get it down. All right? So tomorrow, remind me, and I'll tell you specifically where to zero in for your quiz on Thursday. But you need to be careful, and you need to be reviewing this stuff, and if not, then you're going to find yourself wanting. Because remember, we've been dealing with arithmetic series and geometric series. And so that's what you need to deal with. Arithmetic series and geometric, we need to keep them straight. Today we're going to do series that involve arithmetic sequences, and tomorrow we'll do series that involve geometric sequences. So be careful, review, look over your notes, and try to keep things fresh in your mind, and try to keep things separated. All right, a series is the sum of the consecutive terms of a sequence. A series is the sum of the consecutive terms of a sequence. So all we have below is simply a notation. You know, the capital M, or capital M, the capital S is a sum indicator. It means the sum of the series all the way through to term n. And so what would it be? The first term plus the second term plus the third term. If n were 5, it'd be the first plus the second plus the third plus the fourth plus the fifth. If n was 10, it's the first through the 10th. If n is 100, it's the first through the 100th. And there's all different possibilities. So let's just first off make sure we understand the concept. So you got a series 1, 4, 7, 10, 13, 16, 19, ... And so if we're asking for the fifth term, so just remember, that's the first term, that's the second, that's the third, that's the fourth, and that's the fifth, right? So all they want us to do is add the 1 plus the 4 plus the 7 plus the 10 plus the 13. You're going to add the first 5 terms. You're summing up the first 5 terms of that sequence. So S sub 5 tells you that that's what you want to do. Destiny, if you have any makeup work and stuff for me, you'll need to turn that in, put that on. You got it there already. All right, good, thank you. Okay, so you're just summing up those first 5 terms. Grab your calculator, belt that out, and I think you get 35. Anybody concur with that? We good? Okay. So you're just adding up the first 5 terms. You know, you can see as the number gets bigger, then, you know, the further you got to go. So look, if I just did S of 5 and now I'm going to do S of 8, would you agree I could do S of 5 plus A of 6, A of 7, and A of 8? I could kind of do a shortcut, being already added up the first 5. Does that make sense? And again, you can start from the beginning if you want, but we already figured out the first 5. So what do we got? 35. And we know the 6th term is 16. And the 7th term is 19. And oh no, we don't know the 8th term. Can't do the problem. But then again, we're doing arithmetic sequences, and they have a common difference. And therefore, the next term has to be 22, right? So then just add up those. And I believe we get 92. So not a big deal. So sometimes they'll give it to you this way. They'll just show you some of the terms of the sequence, and they'll say find S sub 5. You'll see the capital S and say, oh, that's a sum. They want me to sum the series, and I'm going to add the first 5 terms. So go ahead and do that. You do it at your seat. I'll do it up here at the same time, and we'll see who gets to Scotland before you. What do you got, Kayla? That's what I got. Right. So again, you saw the common difference was 10. Therefore, the fourth term was 27, and the fifth was 37, and away you go. Now, that's pretty easy to do. And if I give you a sequence and I'm asking for, the first 5 terms of a series, you can go that route. If I ask you for the first 3 terms of a series, you could definitely go that route. Even something as far as 7 or 8, you can go this route. But what if I ask you to sum up the first 100 terms? Then you need some formulas. So that's what's next on your paper there. So these are called partial sum formulas, because if you're dealing with an infinite series, like example B that we just did, it's infinite, right? It's got the 3 ellipses. It goes on forever. So we're not finding the sum of the whole series. We're finding the sum of a part of the series. In this case, in B, we did the first 5 terms. So we did a partial sum of the series, the first 5 terms. And that's the idea. All right, so there's 3 different formulas. You might say, I don't want 3 different formulas. Well, some of them have value in certain situations. All right, so the first one, if you think of it this way, average the first and the last term. So that would be a sub 1 plus a sub n, and the average you would divide by 2, because that's 2 terms. Now we're almost there. We only need one other thing to get the partial sum formula. So you average the first and the last, that's a sub 1 plus a sub n divided by 2, and the only other thing you need to do is multiply it by n, and you'll get the sum of the sequence. So if we try that right here on B, so average 37 and a negative 3 is a 34. 34 divided by 2 is 17. And 17 times 5 better be 85. And it is, right? 17 times 5 is 85. So again, I think if you'll get in your mind, average the first and the last, and multiply by n, then you'll understand that formula, and you'll be ready to go. This is just another form of it. It's just n over 2 times a sub 1 plus a sub n. No big deal there. Those 2 are really the same, just a different look on it. But again, the whole basis, if you'll get in your head, average the first and last term of the series, right, and then multiply by n. There you are. And don't forget, average means add the first, add the last, divide by 2. All right, the last one has a use to it, and so it's n over 2, 2 times the first term, plus n minus 1 times d. So it's real close to the recursive formula, explicit formula for an arithmetic sequence. The only thing is you have 2 times the first term, and you still have the n over 2. You might say, well, why would you use this formula? You can use this when you don't know the value of the last term. Use if you don't know the value of the last term. Because you don't need it, because there's no a sub n. So if it were me, I'd concentrate on the first one. I think the first one's easy to remember, and then I'd concentrate on that last one, because there's times you're not going to know the last term. Could you find the last term? Yes, you could find it another way. You could use the explicit formula and figure it out, but the formula just takes all that into account at one time. All right, it's just a means of figuring out that last term. All right, so let's do a couple sequences here using the formula. So on this one, they want you to do S sub 12. So we want to sum the first 12 terms. And I don't even know how many I wrote here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so we're only going up through the 26, right? So again, in my mind, the easiest way to do it is to average the first and the last of the series, and then you're multiplying times n, right? And what would n be in this situation? 12, right? Because you're doing S sub 12. So the n is a 12. So go ahead and punch that out. So basically you have just 6 times 19, or 12 times 19 divided by 2, however you want to look at it. And somebody let me know what you get when you get it. Who's got it? Dolores, what do you got? 114. Everybody concur? So obviously that's a whole lot quicker than sitting there and summing up 12 terms. And if that was 112 terms, that'd be so much more quick, so much quicker. All right, so that's the situation. Use the formula to find the sum of the integers from 1 to 100. So this is a different sequence. But again, if you use this first formula, it's pretty simplistic. All right? So see if you can figure out the sum of the integers from 1 to 100. 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 all the way up to plus 100, right? That was the question. So hopefully you figured out that a sub 1 is 1 and a sub 100 is 100, right? And n is 100. So you're doing s of 100. Anybody got an answer for me? Nobody did the 100 times 1 plus 100? What is it? 5,050, right? Because the first term was 1, the 100th term was 100, average them, so 1 plus 100 divided by 2 times n, which is 100, and there you are, 5,050. So sum the first 100 digits. That's kind of a question they like to give on an ACT, SAT, a question similar to that. Maybe they'll say sum the even integers from 2 to 100. Just be careful, make sure you get the right amount of digits. Okay, got to be careful with. And away you go, something like that. All right, the last situation, find S sub 125 for the sequence 7, 12, 17, 22, ... So if you go to do it the way we just did it, you say, okay, I have to average the first and the 125th term. I know the first, I don't know the 125th. So what are you going to do? How are you going to solve it? Like, use the formula to where you don't need to know the last term, right? I mean, that's the easiest way if you know the formula. So go ahead and use that last formula there. And go ahead and solve it. 35 grand. 40 grand. Of course, right? Because you're just following a formula, and life's pretty easy if you're following a formula, right? All right, how are you going to remember that one? I don't know. I mean, it's, you got a sub 1 plus n minus 1 times d. That we already knew. So you got to double the a sub 1, and then it's n over 2. So it's not all that bad if you know the a sub 1 plus the quantity n minus 1 times d. And then all you got to deal with is n divided by 2. All right, so real handy if you don't know the last term. Real handy if you don't know the last term. So 125 divided by 2 times 2 times 7 plus 125 minus 1 times 5. Voila. All right. Everybody knows that that is the Greek letter sigma. Have we done any sigma notation in here yet? Okay. So sigma notation. And do we have any Greek people in here? I think that's capital, right? Is that the capital sigma? I'm pretty sure it's capital sigma. All right. Sigma notation is used to represent the sum of the terms of a sequence. So instead of doing S of n, we can do sigma notation, and you're supposed to know, oh, that means find the sum. So when you see sigma, you got to think sum, and now you got to know all the other things, right? This is the first value. This is the last term. Tells you how many you're going through. Like we just did 125 terms, right? So n would be 125. If we were going to sum the first through the 125th, the bottom would be 1 and the top would be 125. And you're saying, oh, I'm summing the first 125. What comes here is usually the explicit formula, which then tells you how to find the first term and the 125th term, and away you go if you're going to use that summation formula. So that's the idea and that's the situation. So let's apply it. So if you look at B and you have sigma notation, you're saying to yourself, I need to sum the first, how many terms? 4, right? First 4 terms. And so you need to sum them. What would be the first term? K would be a 1, right? What would be the second term? K would be a 2. What would be the third term? K would be a 3. And what would be the fourth term? K would be a 4. All right, you're going to sum up the first 4 terms. And so it's 3 plus 6 plus 9 plus 12. And all of that is 30. Sigma notation. Okay. So you see the sigma, you say I'm summing. The bottom tells you what value to start with for the variable first, and the top tells you how many terms. 4 terms. So go ahead and do C. Sum the first 5 terms of that series. You're finding the partial sum of that series. Plus 11 plus 12, and that is what, 50? Okay. Sigma notation, not too bad. Okay, so let's just deal with one situation here where that bottom value is not 1. Just want to make sure that you guys understand what to do on this. All right, so if I go to show the summing of this, would you agree we got to put 3 in for the K for the first term? Why does that bother me? I don't know. It shouldn't. Okay. So that's the first term. Why did I do 7? What was I thinking? Boy, that is bothering me. Why is that bothering me? It shouldn't bother me. Gotta be. All right. Let's just keep rolling. But it's bothering me. So 6. And we stop at the 7th term. Okay, now it's not bothering me so much. Start at the 3rd, so K is 3, and end at the 7th. I'm pretty sure I'm right, but I'm not going to tell you 100%. So, again, as I told you earlier, sequences and series are tricky to me too, and I have to review them to make sure I'm on. And I think I'm right, but I'm not 100% sure I am, but I think I am. And what I would do if I were doing the problem, then I would do something like this, and then I'd check it. And obviously in class, I'm not going to have time to check it right now. So what is that? A 3, that's a 5, that's a 7, and that's a 9. So what do you end up with? 16, 21, 24, 25. Boy, I hope that's right. All right, 16, 21, 24, 25. I think I'm right, I hope. Leah?
So you'd only do 5 terms?
Yeah, because I'm pretty sure we started at the 3rd and we end at the 7th. That's the part that's bothering me right now. But I'm pretty sure I'm right. Because you got to start at the 3rd and end at the 7th. I hate to leave you hanging. What I would do is check the text. And if the text doesn't help me, you know what I'm going to do next to make sure? I'm going to Google it. So this is what I'm going to do too. I think I'm right. I'll tell you tomorrow for sure, but I'm going to check it myself. And I did that when I did it. And honestly, I changed my notes because I think my notes are wrong. But maybe I should have gone with my notes, but I think my notes are wrong. So I think that's what it is. All right. I hate leaving you hanging, but that is the case there. Hey, on these formulas, the plus signs didn't come over, so just make sure you get your plus signs in there. Okay, what in the world? So write a simplified expression of each series. Write a simplified expression of each series. What I did was I took this form and used it in the sequence to write a simplified expression for each series. Okay? So, let's go ahead and write off some terms here. What would be the first term of this sequence? Would be 2, right? Because when first value of k is 1, 1 and 1 is 2. The next would be a 3 if you want to write a few more. But again, summation is 2 plus the second term would be 3. The third would be oops, got a comma in there. 3 plus 4 plus ... On and on and on you go. Okay. All I was after really was a sub 1. Let's use the formula n over 2. So next comes the 2 times the a sub 1. And again, what is a sub 1? It's a 2 in this case. Could have been anything. Plus the quantity. And we've got n still minus 1. And what's the value of d on this? D is 1, right? And so what we have to do is simplify this. So you basically end up with, inside the parentheses, that's a 4. That's just an n plus 1. Here, so I'm going to go to the right. So not to confuse some of you, right now I'm at n over 2 times 4 minus 1 is 3. 3 plus n, are you okay with that? Right? 4 minus 1 is 3 plus n. And then you just got to finish it up. So usually we'll not make this thing squared. So S of n is going to be n times the quantity. Usually put the n first, n plus 3 over 2. And that would be a simplified expression of the series. So really what the key was, we had to find a sub 1 so that we could sub into that last formula. We did also have to know d, so we can sub into that last formula. If we know a sub 1 and we know d, we can sub into the last formula, and away we go. So that's the same concept on the last one. Although the last one's a little boring. It's kind of interesting. So what's the first term of this last one? What's the first term? 11. What's the second term? What's the third term? All right. Really interesting series. What's the value of D? 0. All right. So n over 2 times 2 times 11, right? 2 times the a of 1 plus n minus 1 times d, which is 0. So where do we end up with? 22n divided by 2, which is 11n. Whoa, 11n. And by the way, any series like that where it's just 11 is going to be the case. Okay. What if you had to sum up the first three numbers? Wouldn't it be 11 plus 11 plus 11, or 3 times 11? Right, because then it's 3. What if you had to sum up the first 50? 11 plus 11 plus 11 50 times, or 50 times 11? All right. Key is use the last formula. All right. Oh, I changed the homework here again. So let me tell you what I changed it to. Stop the presses here.